to talk about op-amp negative feedback. Almost like we never left. So in addition to making the amplifier input and output impedances approach their ideal values, remember ideally the output impedance is equal to 0, the input impedance is equal to infinity, ideally. Negative feedback returns a portion of the output signal back to the input with a 180-degree phase shift. And that's what makes the amplifier stable, so there's no tendency for it to develop runaway oscillations. Okay. All amplifiers incorporate negative feedback. All right. So care must be taken to avoid driving the output stage into saturation. So you don't want too much voltage gain and/or too high an input voltage to saturate the outputs. Because for an amplifier, that's not what you want. Okay, so anyway. Okay, the non-inverting amplifier input and output signals are in phase. Okay, so here we see a non-inverting amplifier. Okay, again, we're going to the non-inverting input, positive. This is the input signal Vn. This is Vn. These two resistors provide our feedback. So RF is the feedback resistor. Ri is called the input resistor, and the formula for the one-step formula for calculating the voltage gain. And yeah, we're going to go over this quite well in class. Okay, it's there. It's a real easy formula. Here's an example, so you can just follow it through. But and you can express the voltage gain as a ratio, or as a dB. Okay, notice that the input and output, right, have the same phase relationship. If you're to overdrive the amplifier, you're going to get distortion, right, and clipping. This is not what you want. Okay, so this is a non-inverting amplifier. Okay. Inverting amplifier, the input and output signals are offset by 180 electrical degrees, as you might have guessed. So, okay, so we're going into the inverting input. The non-inverting input is tied to the ground. Okay, so this is, again, the input, like that. Input resistor Ri, feedback resistor RF. No, this is really exciting. Okay, and the formula is going to be just like that. Okay, negative RF divided by Ri. There's, sorry, why must be my mouse. I'm sorry, guys, but I'm sure it does that. But there's a sample calculation. So again, we'll be going over this in class. Key thing is that the output signal is amplified and inverted relative to the input. You can notice the phase shift. Okay, so there's the inverting amplifier configuration. There's the non-inverting amplifier configuration. Okay, learn them well and be able to recognize them, because they'll definitely be seeing it over and over again. Okay, a voltage follower, input and output signals are in phase. We talked about that, I think, in the last slide. No feedback resistors in a voltage follower, and they're used for buffer isolation circuits. And notice the feedback from the inverting input to the output. Okay, so key characteristics: no phase shift. Okay, output signal is in phase. Output voltage equals Vn. The gain is equal to 1 or 0 dB. Has really very high input impedance and very, very low output impedance. So it has a lot of applications. Okay, and that's the end for this one, and we'll see you next time around. Okay, bye-bye.